Welcome back to solving exponential equations, and now we're going to take a look at some exponential equations that are in quadratic form. Now remember that in order to solve an exponential equation, it's very important to identify the type of exponential equation we're dealing with so that we choose the correct strategy to solve it. And quadratic exponential equations are fairly easy to solve. So the first thing we have to do is identify or determine whether the equation is in quadratic form. And the things we look for are first the number of terms. So normally the number of terms will be more than 2. So in this case we have 1, 2, 3 terms. Next we look at the exponent. So the exponent will appear in at least 2 terms. And what you see in here is the exponent x, and in the other term, the exponent is double x. So normally, if the power is x in one of the terms, you will see that in the other terms, the power will be double of power x. And in some cases, the coefficient of x in the power can be any even number, okay? So we're going to take a look at some examples that provide more variety there. So in order to solve these equations, we treat them obviously like quadratic equations. So we are going to take all the terms to one side of the equation. So we have 5 to the power of 2x minus 5 to the power of x. Bring 20 to the left side, minus 20 equals 0. So now, in order to show the quadratic form more clearly, so what we're going to do is we're going to change the look of this term, let's say. So 5 to the power of x can to the power of 2 would be another way of looking at 5 to the power of 2x in here. And then we have minus 5 power x, and then minus 20 equals 0. So as you can see in here, we have 5 to the power of x squared minus 5 to the power of x minus 20 equals 0. So if you replace, or if we replace the 5 to the power of x by some, literal variable a, so we have, let's say, a representing 5 to the power of x, look at what the equation is going to look like. So we have a to the power of 2, and then we have minus a, and then minus 20 equals 0. So we can clearly see now that this is a quadratic equation. We can easily solve this by either using factoring or quadratic formula. Why not? So I'm choosing factoring, is easier this way. And we need to find two numbers and multiply to negative 20 and add to negative 1. And what we have is negative 5 and positive 4. So therefore, we're going to say that this equation is true if either a minus 5 is 0 or a plus 4 is 0. So that means that a can be 5 or negative 4. And now we are thinking, wait a second, so we were solving for x here, not for a. So what is x? So now it's time to bring back 5 to the power of x. So since 5 to the power x mean the same thing, then we're going to say, okay, so 5 to the x is 5. So if you compare the coefficient, the powers in here, you see that the powers must be equal, obviously, because the exponential numbers have the same value, so x equals 1. That's a solution we derive from the first factor. And next we have here, similarly, we're going to say 5 to the power of x equals negative 4. So as you can see in here, you have a positive base, and a positive base raised to any power cannot be negative, which means that we don't derive any solutions from this factor. So therefore, the only solution to this equation will be x equals 1. Okay, so we're going to practice this strategy in the next example. So you can try this on your own, obviously, that's even better. So I will continue solving it. And we have, in this case, the base 3 to the power of 2x minus 5 times base 3 to the power of x, and that equals negative 6. So as you can see, again, we have 1, 2, 3 terms. Okay, so all good signs of a quadratic equation, we have 3 to the power of x here and 3 to the power of x with a coefficient 2 here. So which means that we can convert it into 3 to the power of x squared. And then we have minus 5 times 3 to the power of x. And then bring negative 6 to the left side, plus 6 equals 0. So if you wish to use what we call the helping variable, so a, then this equation can also look like this. So we have a squared minus 5a plus 6 equals 0. So this is a quadratic equation which we can solve by using factoring. And we have a minus 3, a minus 2 equals 0. So we'll solve for a first. So we'll have a equals 3. So, or a minus 3 equals 0. You get the idea. So that means a equals 3. Or a minus 2 equals 0, where you get a equal to 2. So now we're going to solve for x. So remember that a represents 3 to the power of x. So we're going to say 3 to the power of x equals 3 to the power of 1, or 3 to the power of x would equal positive 2. So in order to solve for x, we are going to compare the exponents. In this case, it's easier. So we're going to say that x equals 1. Or in the other case, here we have 3 to the power of x equals 2. So we don't have the same basis, but we know how to solve such equations. So we looked at these equations in the previous lesson. So we're going to convert this to logarithmic form. So that would be log with base 3 of number 2. And these would be the exact answers. So x equals 1 and x equals log with base 3 of 2. So if you need, obviously, the approximate answer, we are going to use the calculator. So that would be log of 2 over log 3. And here we go. We're ready for our next example. So the next example looks a little bit different. Not that different. So what you see in here is 4 to the power of x. So that would be our central variable. And we don't see 4 to the power x repeat anywhere else. We do see that we have 3 terms, so that might be an exponential equation in quadratic form. So we are going to look into the term that contains x in the power and try to convert it to a base 4, since we already have a 4 to the x here. So number 16 can be written as 4 squared and then to the power of x, and then minus 5 times 4 to the power of x, and then plus 4 equals 0. And we're going to write 4 squared to the power of x. Remember that these two powers will multiply. So I am showing all the steps, but if you already see the solution in here, so obviously it's a step that you can skip. So you can write the next step as 4 to the power of x squared. So you can kind of swap these two, right? And minus 5 times 4 to the power of x plus 4 equals 0. So what this new example brought in is the fact that sometimes we need to work on the terms that contain the variable, and we need to make the basis the same. So as you can see here now, we have a quadratic equation. So we can bring in the helping variable a. So we let 4 to the power of x equal a. And then we have a to the power of 2 minus 5a plus 4 equals 0. So solve by factoring. And in this case, we have a minus 4 times a minus 1 equals 0. So the solutions would be a minus 4 equals 0 at a equals 4, or a minus 1 equals 0 at a equals 1. So remember that 4 to the power of x is a, so 4 to the power of x equals 4, or we're going to say that 4 to the power of x is 1. So if 4 to the power of x equals 4 to the power of 1, that tells us that x must be 1. And is if 4 to the power of x equals 1, that tells us that 4 to the power of x must have been 4 to the power of 0, which means that x is 0. Or you can simply find the value of x by taking the log with base 4 of 1, which is basically 0. So therefore, we're going to say that we have two solutions in this case. One is at x equals 1, and the other is at x equals 0. So the next example is an example you can try on your own. There is something new that this example brings in the strategies that we use when solving exponential equations. So let's take a look. So what is different between this equation and the previous ones? As you can see here, you have a negative power. When you see a negative power, you got to convert it into a positive power before you start solving an equation. But I'm very happy to see that the bases in the exponential parts are the same, so I don't need to do any work there. So I will rewrite this equation as 6 to the power of x plus 36, and here 6 to the negative x will be in the form 1 over 6 to the x, and I will bring 37 to the left side because this will be a quadratic equation. And next we will have to get rid of the denominator. So the lowest common denominator here will be 6 to the power of x. So as you can see, we created a denominator here. So we are multiplying by 6 to the power of x every term in the equation. So we have 6 to the power of x times 6 to the power of x plus, remember when you multiply here by 6 to the power of x, this will simplify, but we are going to show the steps here, obviously. So we have 1 over 6 to the power of x, and then times 6 to the power of x, and then minus 37 times 6 to the power of x. And obviously we can multiply 0 by 6 to the power of x, but that won't change anything. So as you can see in here, the multiplication of 6 to the x times 6 to the x will be 6 to the power of, remember that we're adding the power. So I'm going to show all the steps, but obviously here you can skip the step and write just simply 2x. And the 6 to the x and 6 to the x here simplify. We have plus 36 here, minus 37 times 6 to the x equals 0. So now let's rewrite this. We have 6 to the power of 2x minus 37 times 6 to the power of x plus 36 equals 0. So I reordered the term and left the constant for last. So you can see here you have one term here, 2 terms, and then 3 terms. So 6 to the power of 2x can be 6 to the power of x squared. And then we have minus 37 times 6 to the power of x plus 36 equals 0. So we're going to follow now the same strategy. So we're back to the same format that we have of equations that we solved before. So we're going to use a helping variable. Now, using a helping variable is not a must do step, so you can just factor from this form, and I'm going to show how. So here we have a helping variable a, which is multiplying, in this case, it's brought to the power of 2 and then minus 37, and then we have a, and then we have plus 36 here equals 0. So let's factor and see what we get in here. So we have a minus 36, a minus 1 equals 0. So from here, we obtain a equals 36 or a equals 1. So that means that 6 to the power of x equals 36, or 6 to the power of x equals 1. So 6 power x equals 36 is 6 squared, so that means x equals 2. And this will be our first solution. And the other solution is obtained from the next equation, where x can be obtained by converting into log statement, or simply convert it to 6 to the power 0, the right side, where x equals 0. And this will be our second solution. So again, as you solve a new type of quadratic equation, or as you discover new strategies, try to articulate and write them down. So what are the different occasions or cases that you see? So you can convert the bases to make them the same, or when you have negative exponents, you have to convert them to positive exponents, or in other cases, what we have to do is simply convert the equation into a visibly quadratic format, so which is very helpful. Now, as I said before, you may or may not have to use a helping variable. So as I was saying in here, we use the helping variable, but if you would wish to factor from this form, then you can very easily do so. And I'm going to show you this here in green. So you can factor this by simply focusing on the coefficients, which are negative 37 and 36. So you know that you are dealing here with 6 to the power of x. So that would be the first term in each factor, and then you have to factor two numbers that multiply to positive 36 and add to negative 37 are negative 36, negative 1, and you can solve from here. And eventually I would prefer that we go towards or lean more towards this format. Well, thank you for learning with me, and I hope these instructions were helpful, and I hope this all made sense. Bye for now.